Okay, let's take a look at number 6 here. It's Foundations of Math 36.4, number 6. And we're going to go through this. We're talking about curves of best fit. We're also going to get the graphing technology to calculate the line or the curve for us. So we're going to go over all the points here, and this is kind of how you do it. So number 6 says, a dolphin jumped out of the water in a tank and then dove back in. The dolphin's height in meters above the water is given in the table below. Using quadratic regression, estimate the maximum height that the dolphin gets during the jump. So we're going to use quadratic regression. Is it frozen still? We're going to use quadratic regression. That means we're going to input the points into the calculator. We're going to ask the calculator to determine what the quadratic equation is for the collection of those points. And then we're going to estimate the maximum height of the dolphin during the jump. Okay? So you're going to get your graphing calculator out. And if you are at home watching this, you're going to get some kind of graphing technology, maybe that you've downloaded on your computer, or maybe you have one of these at home. But this is the calculator we're using in class here today. And so what we're going to do is we're going to go to Stat. That's very important, the Stat button. And we're just going to hit Enter for number 1 to edit lists. Now, if you have numbers in here, okay, and you want to clear that list, you just go up and you hit Clear on the calculator and then Enter, and it will clear list 1. Do not delete list 1, just clear it. Okay, so what we have to do is we have to pick so height and time. So which one is the independent variable on the horizontal axis, and which one is the responding variable or the measurement variable? What do we actually measure? So you want to look at this and you say, well, obviously time is passing, and usually when there's time passing, that's the independent variable. It goes on the horizontal, that's the x. So let's put in our times for x here in list 1. So 0.5, and then 1, and then 1.5, and then 2.5, and then 3.5. Okay? So 0.5, 1, 1.5, 2.5, 3.5. All right? So let's go over to list 2, and then we'll put the heights. Now what we measure is the y variable, right? What we measure. So we're going to measure the height at different times. So this is going to be 0.59, 1.22, 1.39, 0.73, and then negative, and here's your negative button on your calculator. Don't hit the minus. You got to put the negative if you mean a negative value. And it's negative 1.45. Okay, so let's notice a couple things here. Over time, the dolphin jumps out of the water, and these get higher, and then they get lower. What's up with this negative height? What does the negative height mean, do you think?
It's already in the water.
Yes, it's under the water level. Very good. So this height is the height in meters above the water level. Okay? All right, so we've got our points in here. Now let's plot the points, but first of all, we need to go to second function, y equals, which is the stat plot menu. Come on, second y. Stat plots. Now we need to turn one of these plots on. Okay? They'll be off. They might be off, so you need to turn it on. So turn plot 1 on. This is the type by default. That's great. The x list, we did put our x values into list 1, so that's perfect. If you need to change those, just cursor down and then hit second function number 1. That'll put in list 1 in there, or whatever list you used. So x values in list 1, y values in list 2. The mark doesn't matter. Okay. Now the window is also something we're going to want to probably adjust. The time, there's no negative times obviously, and we're going to go to like maybe 5 seconds. So let's go from, the x is going to be from 0 to 5. Okay. The y, so the smallest y value that we have is 0.59 meters. The largest is 1.39. So let's go, we can go from 0 again here. We can go from 0 if we want to, let's go 1.5 maybe. 1.5. Now, we actually have negative 1.45. That's our lowest. So let's go back and adjust this minimum to negative 1.5. Okay, that'll be better. So now if we hit the graph button over here, hit the graph button, you should see your 1, 2, 3, 4, 5 points. So if you were to imagine a smooth curve connecting these points, it would look like a parabola, right? And so a quadratic regression is reasonable. That's what we're looking for, quadratic. So who remembers what we do next? To find quadratic, what buttons do I push? Okay, stat, very good. Over to calc, yeah. Very good. Down here, and number 5, we see quad reg down here. So you're going to hit number 5 or go down and hit enter on number 5. And then you'll have this. Very, very good. Okay, so we're telling the calculator, hey, I want you to figure out a quadratic regression function. Then what do we need to tell it? Second function. 1 for list 1. Comma. Okay, tell it the y value is list 2, so x comma y. Then we're going to do one more step, remember, to save ourselves some time in copying this out. I'm going to do, comma, vars, over to y, vars, function, and we're going to put the all the data into, let's do just y1. Okay. So we're going to ask the calculator to figure out a quadratic regression function using list 1 as the x, list 2 as the y, and I want the calculator to put all that data into y1 so we can graph the line or the curve of best fit. So you hit enter now, it'll think for a couple seconds, and then it'll show you this. So if you were writing out on a test or a quiz, you're writing out the quadratic regression function, you would type out y equals negative 0.7467 x squared plus 2.3 x minus, because it's a negative, minus 0.36445, or just use as many decimal places as you want. Usually 2 to 4 decimal places would be acceptable for stuff like this, okay? And so that's how you would literally write that. And I'm going to, you know what, I'm going to just clip this, okay, over here, and show you. So when this is on the screen, you're going to write, here's the regression function, is going to be y equals negative 0.7467 x squared plus 2.303 x minus 0.3645. Okay, that would be perfectly acceptable for stating the quadratic regression. So let's just check and see what that looks like when we hit graph now. So we should see the points, and we should see this quadratic going through here. Awesome. Okay, so that is the path of the dolphin given these data points. Okay, it looks pretty good. So what does it say? Estimate the maximum height. Okay, so the maximum height looks like it's going to be pretty close to this point right here. Now, it's not going to be exact, but if you hit the trace button, just the plain old trace button, look at what's up here, because we've got two things plotted. We've got the points, which you see on the top left of your screen. It says point 1, L1, L2. And then if you cursor over, it'll highlight point 2, and so on. The third point, fourth point, fifth point down there. But we don't want that. We want the function. So let's just cursor down. And now up here it shows the function. You see? This is the function that we've put in. So go back to graph, go to trace. And what you could do is you could kind of like move your cursor around. Oops. You could move your cursor until it's pretty close to the top, but that's not very exact, is it? And you could check out this y value. So it's going to be pretty close to 1.4 something. But let me show you how to find the exact maximum value with the calculator. And I've made a video on this, but we'll go over this anyways. I'm going to first of all change the window. My y max I'm going to make a little bit bigger so that I have a little more room up there. Oh, what did I hit? That was not what I wanted to do. Oh, I changed the x max. My bad. X max. That should be. Let's go back to 5. Where is the y max? Here we go. So I'm going to do like 7 or something. So I can see up there. Now, it's squashed down a little bit, but that's okay. This is going to be good. So we're going to do second function trace, which is the calculate menu. And we're going to look for maximum. You see number 4 there? Maximum. So I'm going to hit number 4. And then this screen's going to come up. So just like we did for the x-intercept, we're going to do the same thing for the max. So what you have to do is you have to move your cursor back until it's to the left of where the perceived maximum is on this. And so I'm going to go way over here. And it says left boundary. And I'm going to say, yep, enter. So you have a little marker there. And then it's going to say right boundary. So move your cursor over to give it a right boundary for its search for the maximum point. So there we go. That's clearly to the right of what the maximum would be. So I hit enter again. I have a second little marker there on my screen. And so the calculator says, do you want me to guess now what the maximum is? I've got the markers. So yes, hit enter, and it'll think for a moment. And then it should show you the x value and the y value of the maximum point. You see that? So the maximum is at time 1.54 seconds. Okay, 1.54 seconds, so right in here somewhere. The maximum height is 1.4118 meters. So it's this point right about here in our data. So what's the maximum height? 1.41 meters is your answer for that. Max height is 1.41 meters. And then you'd also show your regression function that you used to find that. All right. Any questions at all about what we did with the calculator? Okay, so let's go over real briefly here again what happens when we do when we find this regression function and all that. So quad reg calc menu quad reg. Then you're going to do list 1, comma, list 2, comma, vars over to yvars. Okay. So hit the vars button, which gets you to this one. Then you go cursor over to yvars. Okay. And then just hit enter and then put it in whichever function you want, which one. And then you hit enter again, so you have those 3 up there, and then this is what it calculates for you, what we just did. And then if you look over in y equals, it shows it has the full equation there of the quadratic function already put in. Then you hit graph, and you have your dots from before, and you'll have your line of regression. Okay? Good question. Any other questions? You guys good with that? All right.